The northern and southern regions of Mars show a vast difference between each other, known as the Martian dichotomy. The northern lowlands and southern highlands each have unusual geological features, including differences in elevation and surface characteristics. This phenomenon has been a subject of scientific interest for decades. The northern lowlands make up only about one-third of Mars' surface. It forms a smooth, flat expanse that is on average 4 to 6 kilometers lower than the rest of the planet's surface. Included in this region are the vast plains called Acidalia planitia, Utopia planitia, and Tris planitia, as well as enigmatic features such as the Borealis Basin, believed to be the largest impact basin in the solar system. Evidence of volcanic plains suggests that lava resurfacing played a significant role in shaping the lowlands. Volcanic features, such as those in Elysium planitia, hint at recent volcanic and possibly other geological activity on Mars. Features such as outflow channels and deltas such as those found in Jezero crater suggest episodic flooding events. The hypothesis of a past northern ocean is supported by the detection of sedimentary deposits, shorelines, and water-altered minerals. Radar data from missions like MEMAR-SIS have revealed potential subsurface ice reservoirs, indicating that ice-rich layers may underlay parts of the lowlands. This suggests the possibility of cryovolcanism, where icy materials instead of molten rock reshape the terrain, remains an intriguing research area. The southern highlands have large craters like Hellas, Planitia, and Argyll Basin, which are massive impact scars. This region preserves a record of a time when Mars was more volcanically and hydrologically active. Hellas Planitia is unique in that it is deep enough that you could actually have liquid water at the bottom. Valley networks, such as those found in Nergal Vallis, suggest widespread erosion from a time when liquid water was stable on the surface. The highlands also show signs of chemical weathering, with clay minerals and sulfates indicating interactions between water and rocks over extended periods. The thick, igneous crust of the highlands contrasts with the thinner crust of the lowlands, much like as you see between the continents and ocean basins on Earth. Geochemical evidence indicates that the southern crust may be enriched in radioactive heat, producing elements potentially influencing volcanic activity. Catastrophic Martian geology is a model of Martian geology where Hellas Planitia impact and other large impacts occurred over a fairly short period. This affected Mars' temperatures and atmospheric conditions, allowing for liquid water on its surface. The key is the fact that Hellas Planitia is exactly opposite the Tharsis volcanoes, including the tallest mountain in the solar system, Olympus Mons. The center of Hellas is directly opposite the western side of Alba Pater's caldera, suggesting a causal relationship between the two. The dust from the impacts and volcanic eruptions would have increased the pressure of the Martian atmosphere as well as warming the planet. This would have opened a window of opportunity for the melting of subsurface water ice that could have flowed on the Martian surface, flooding the lowlands. As the planet's geology settled down, stopping the volcanoes and allowing the dust to settle, the planet cooled down. This caused the water to freeze or evaporate, with the ice either ending up at the poles or underground. Future exploration goals in the northern lowlands includes investigating sedimentary deposits for biosignatures or organic molecules, map subsurface ice to understand water availability and its role in shaping the terrain. Future exploration goals in the southern highlands include studying craters and valleys to constrain Mars' early climate and hydrology, analyze clay minerals and sulfates for signs of long-term water-rock interactions. Future exploration goals in the dichotomy boundary includes conducting high-resolution mapping of the transition zone to test formation hypotheses, investigate whether tectonic forces or impacts played a dominant role in shaping the boundary. In conclusion, Mars' northern lowlands and southern highlands are the keys to unraveling understanding the planet Mars and what shaped it. Each holds a unique story, and together they frame the larger narrative of Mars as a dynamic and complex world. If you like this content, please support this channel by making a donation or buying a product through the links mentioned in the description.